This is problem number 3 from assessment number 5. In this problem it says find part A, the slope of the curve at the given point P, and part B, an equation of the tangent line at P. So we're going to use, obviously to find slope, we're going to use the slope equation. And the slope equation we're going to use has a limit to it because we want to find the tangent slope. So we're going to say limit as h approaches 0 of f of x plus h minus f of x all over h. So this is the part that finds the slope. This is the part that finds the tangent slope. So that's the key there, is this will find a secant slope, but this part, when you do a limit as h approaches 0, this helps you find the tangent slope, and that's what we want to find here is the tangent line. So that makes sense that we're going to do the limit as h approaches 0 or the function. We're going to start out by saying that we're going to take this root x function and we're going to plug in x plus h into it. So we're going to say limit as h approaches 0 of root x plus h minus, and then the original function, they want us to subtract f of x, so that's just root x. And that's going to be all over h. And that's going to equal, I'm just going to say ditto for the limit. I need to get rid of these roots because my goal is to cancel the h. I think whenever I see a radical and then obviously two terms here, I'm thinking conjugate. I think I need to multiply by the conjugate. So let's multiply by the root of x plus h minus, no, plus the root of x, and we're going to do the same thing to the bottom, so we're going to multiply by root of x plus h plus root of x. And the reason why we're doing it to both the top and bottom is because this is 1. We want to make sure when we multiply this fraction, we multiply it by 1 so that it doesn't change the expression. When you multiply these, you get x, or root of x plus h times root of x plus h. That just gives you x plus h. Then you get root of x plus h times root of x. That'll just be a positive root x, root, and I'm not going to combine them together. I'm just going to leave it like this, although I can combine them together. It's not going to matter. You're going to see that in a second. Now I take the negative version, or negative root x times this, and I get negative root x plus h. And then negative root x times root x will give you negative, the roots cancel, and that's just negative x. And that's going to be all over h, and I'm just going to leave this in parentheses right here. This will be root x plus h plus root of x. I just think to make it sense to leave it like that. My goal is to cancel h anyway, so there's no reason to distribute or anything like that. Let's start to cancel here. We can cancel out, of course, we can cancel this term with this term, the x with the x, and all that's left on top is h. So we end up with h over h root x plus h plus root x. Now you can see that the h's cancel, leaving you with a 1 on top. Oh, ditto here. So ditto here, and this is 1 over now root x plus h plus root x. So we're going to take now the limit as h approaches 0 for this function, and we end up with 1 over root x plus 0 plus root x, which will end up being 1 over root x plus root x, which is equal to 1 over 2 root x. All right, that worked out. H is gone, which was our problem, right? Because we couldn't plug in 0 right away. And we're left with this expression for our slope. So now we're going to say that at the point 9, 3, we're going to find the slope. And to find the slope, we say 1 over 2 root, and we're going to plug in for x, our x value, which is 9, Root of 9 is 3, so we get 3 times 2, which is 6, so this is 1/6 for a slope. Now we're going to find the tangent line. So this is part B now. We just found part A. Let's go ahead and circle that up. And now we're going to find the tangent line for part B. Well, to find the tangent line, we want to use the slope that we just got. So we say y equals 1/6 x plus b. We're going to plug in the coordinate 9, 3 that we've got right there. So we get 3 equals 1/6 times 9 plus b. This will give you, well, it'll give you 9/6 plus b. This is really just 3/2, right, if we divide them both by 3. So we end up with 3. I'm going to subtract that over, so it's minus 3/2 equals b. Common denominator, so I get 6 over 2 minus 3 over 2 equals b, which equals 3 over 2 for b. So my equation for the tangent line is y equals 1/6 x plus 3 over 2.